So in this problem, we have to find out the magnitude of the resultant force and its direction, which is measured clockwise from the horizontal. So please understand, first and foremost, we have to identify the coordinate system. This is your X, this is your Y, and you have two forces, FA and Fs. This angle is 60 degrees. This angle is 40 degrees. So to find out the resultant, we have to find out summation of forces in the x direction. So in last class, I told you about this trick. So whenever you want to resolve a component, make sure origin of the coordinate system is located where the vector starts. So if you see, this vector is in this direction. This angle is 60 degrees. So f of x is equal to fa sine 60. It is positive because it is in the same direction as positive x-axis. Then you have f of s, and again f of s sine 40 plus f of s sine 40. Now summation of forces in y direction. Now you have fa cosine theta, which is plus fa cosine of 60, and you can see that the cosine component of fa is in the same direction as positive y. On the other hand, if you look at the cosine component of fs is in the opposite direction of y, so you have minus f of s cosine 40. What you need to do is fa is equal to 8 kilonewton. So you would substitute fa is equal to 8 kilonewton, and you are going to get the values for f of x. You can tell me real quick. You can sum for f of y. You'll get value for f of y. The resultant is going to be square root of f of x square plus f of y square, and c is going to be tan inverse of f of y divided by f of x. And if you have your calculator, you can quickly tell me the answer. How much? 4.
5 is 6.9.
Resultant 10.8. Yeah, about 10.8 is correct. And tan inverse of f of y by f of x. What's that angle? Everyone understood this problem? Next problem. So this problem is also exactly the same problem. If the resultant force acting on the support is 1200 pounds, please understand the resultant force is nothing but square root of fx square plus fy square. Now what it means is please try to understand. In this problem, you start with identifying the coordinate system. You start with identifying the coordinate system x. Identify the coordinate system. Summation of f of x is equal to f cosine of theta plus 900 sine of 60. Summation f of y is equal to f sine theta. And please note it's going to be minus 900 cosine 60. Why minus 900 cosine 60? Because if you look at the component of 900 pounds, it is going in this direction. If you look at the component of f, it is going in this direction. So the component in y direction, 900 is opposite to positive y-axis. Next thing what you need to do is the resultant is 1200. 1200 is equal to, you have to square f of x plus you have to square f of y and do the square root. So to solve this problem, you have to square 1200 is equal to f cosine theta plus 900 sine 60 square plus f sine theta plus, minus 900 cosine theta 60 and then square. And when you solve this problem, please understand you have two equations and you have two unknowns. So you should be able to find out the value of f and you should be able to solve value of theta. Now a word of caution. I strongly recommend you work out the math because there is a little mathematical jugglery that you want to do because you are solving a transcendental or a trigonometric relation, not purely an algebraic expression. So please work this problem out and then try to find out the value of theta and try to find out the value of f. If you are not able to get the answers, please look at the solution that I have given you. Everyone understood how to solve this problem? Now let's look at, so this problem I'm going to give you, which is again same as the previous problem. I'm going to assign this problem as homework. It is the exact same problem wherein what you need to do is you have two forces and you have to find out the forces in each member. But I will set the problem up. To solve this problem, we have to draw something called as the free body diagram. So when we construct a free body diagram, we free the bodies. So this is body BA. This is joint A. This is body AC. This is joint B. And this is joint C. And we need to identify what are the forces that are acting on this object. Now, first and foremost, the force, this is the force which is 400 pounds towards right hand side. Now, I want to ask you just from logic, tell me whether AB would be in tension or would it be in compression? Would AC be in tension or would it be in compression? So what would happen? Would AB get pulled or pushed? And AC would get pulled or pushed? Now, do you agree with me? Since point A is trying to go towards right, this AB is gonna get stretched. Which means the reaction force is going to be on the joint, something like this. Now, since this A is going towards right, this force is going to be compressive. So here you are going to have tension, you are going to have compression, and since the action force is compressive, reaction force is going to be in the opposite direction. Now let's go a step further. What's going to happen on joint B and what's going to happen on joint C? So you have the action force shown in red and the reaction force which will be shown in green. So these forces that I have drawn here, this pair, these two pairs, they are called internal forces. These internal forces came into being because we are freeing the body. If these bodies were to be combined, this red force would cancel out green force, this red force would cancel out green force, so on and so forth. And the only force system that would exist is the one that is shown in the figure. Everyone understood this? To solve this problem, what you need to do is, once again, you have to set up the coordinate system. So you have to set up the coordinate system. This angle is theta, and this angle is phi. I don't know if you realize this, but there is a little trick. If you want to solve this problem, it might be instructive to define all the angles with respect to a consistent coordinate system, which means your first force would be at angle theta and your second force would be at angle theta plus p. Are you with me? Then it would be easier for you to resolve the forces in x direction and in y direction. Are you with me? Okay. I want to solve, I have to go through about 20-25 problems. So I'm going to set up the problem, but my hope is that after going home, you will work these problems out by yourself. Before you come to next class, before you take the exam or the quiz, I at least expect all of you to have gone through most of these problems. That would help you immensely. But if you want me to spend some time and solve any of these problems, I would be happy to. Everyone understood how to solve this problem? No? Okay, so this force is F AC. This force is F AB. So you will have to set up the problem. Summation of forces in x direction is equal to plus 400 minus FAB cosine theta plus FAC cosine theta plus phi. Summation of forces in y direction is going to be 0 FAB minus FAB sine theta plus FAC sine theta plus phi. And now what they have spent, they are telling us that the FAC is equal to 500 pounds. FAC is 500 pounds, and I think P is equal to 40 degrees. So you solve this, and then you should be able to get the answer. I would encourage you to work out this problem and then make sure that the answer that you get is same as the answer given in the solution. So now this is the next problem. Now what's happening in this problem? In this problem, you have an eye bolt. So it's an eye. On the eye bolt, you have two rows. One row is going up, it's going towards it's 40 pounds force in that row. The second row has 50 pound force. Now we have to express these forces as Cartesian vectors. Now what do I mean by Cartesian vectors? Cartesian vectors means you will have to express those as a sum combination of i's and j's. So I is the unit vector in x direction. I indicates the direction which is in the positive x direction. You have j, which is the positive unit vector in y direction. Now what I need to do is I have to use the same logic. So this is my y. I'm going to draw a vertical line. I'm going to draw a horizontal line. This guy is going to be 40 cosine 30. C30 means cosine 30. This guy is going to be 40 sine 30. Same thing over here. This guy is going to be 50 cosine 20, and this guy is going to be 50 sine 20. Are you with me? So what I've done is I have drawn the perpendiculars on the coordinate frame. So I have looked at the vector, I've drawn the perpendicular on the coordinate frame, and I have identified the components about in the direction of x, component in the direction of y. Now please understand, 40 cosine 30 is the magnitude of x, magnitude of y component. 40 sine 30 is the magnitude of the x component. 50 cosine 20 is the magnitude of x component, and 50 sine 20 is the magnitude in the y direction. Everyone understood this? So these numbers, they do not represent vectors. They represent the amplitude or the magnitude of vector. Now, if I want to write these in a vectorial form, I would write F1 which is the vector, which is 40 sine 30 I plus 40 cosine 30 J. Are you with me? Because now what you have is you have the magnitude of the vector 40 sine 30 and I hat indicates the unit vector in the direction of I, or unit vector in the direction of x. 40 cosine 30 is the magnitude of vector and J indicates the unit vector in y direction. Question?
Would it be, like, honest factor actually, would it be multiplied after the half of that?
No,
Okay.
but I usually, if you are going to be a roboticist, remember your hats. Because you don't want to confuse your I with imaginary number. Since we talked about imaginary number, this is the time for my joke. Life, don't laugh, I don't crack a joke. Life is complex. It has some real and imaginary components. How do you deal complex problems? Separate the real part and the imaginary part. Most of the time, we worry about the complex problem not because of the real consequences, but the imaginary component associated with that problem. So as long as you can separate out real part versus imaginary part, almost all the problems in life can be solved. Okay. F2. So you have 50 cosine 20 I, and now look, 50 sine 20 is going towards the downward direction, which is opposite y. So which would be minus 50 sine 20. Do you agree with me? Okay. Next problem. In this problem, you have to find out the magnitude of the resultant force. The only problem here is the coordinate system is crooked. Only problem here, the coordinate system is crooked. Whenever you are dealing with a crooked coordinate system, first and foremost thing that you should convince yourself that the coordinate system that you have is the right hand coordinate. So curl your fingers. This is your x, this is your y, this is your z. Align your x. You agree with me that even though this coordinate system is crooked, it is still the right hand coordinate system. And this will save you a lot of headaches. I'll tell you the reason why. If you are going to work with avionic systems that are built in United Kingdom on ARIN standard, they use left-hand coordinate system. So their drones, quadcopters, flight control systems, they use left-hand coordinate systems. The signs will get changed if you use the right-hand coordinate system, DCF transformation, to the angles that are expressed in the left-hand coordinate system. So I have learned that lesson in a very hard way. So anytime you see a coordinate system drawn, don't assume that it's a right-hand coordinate system. Verify. This is the right-hand coordinate system, and now you guys are expert. Can someone help me real quick? What's gonna be here? Come on. This is gonna be, I'm gonna draw a vertical line. Then I'm gonna draw a vertical line. This guy is gonna be F1 cosine 45. Then this guy is going to be F1 sine 45. So this guy is going to be F2 sine 30. This guy would be F2 cosine theta. Are you with me? And then what you will do is, now, once again, it is extremely important that the components, the components of the force, their arrows be in the same direction. And if you cancel out the arrow of the resultant force, can you see that your x component is going, or your y component is going in this direction, x component is going in that direction, but this resultant is cancelling out the summation of x component and y component. Are you with me? This problem, how will you solve this problem? To solve this problem, what you need to do is you will have to add the unit vector in x and you have to add the unit vector in y. Now let's start with F3. F3 is equal to, can someone tell me what is F3? What would be the I component of F3? By now you should be correct. Negative 750 sine 45. Don't forget the I. And plus 750 cosine 45 J. Tell me about F2. Negative 625 sine 30I and minus 625 cosine 30 G. Are you with me? Same thing. Now, the last part is really interesting. They have not given us the angle, but what they have done is they have given us this triangle. So let me show you what they have given us. So what they have is they have given us this triangle. This is 3. This is 5. This is 4. So, and what I'm going to do is, I'm going to say maybe this angle is theta. This angle is theta. So if this angle is theta, you agree with me, this angle will also be theta. Cosine theta is equal to 3 by 5. Sine theta is equal to 4 by 5. Do you agree with me? Because there they have not given us the angles explicitly, but they have drawn the triangle so that we can identify the angles. And F3, so F1 is equal to F1 sine theta I minus F1 cosine theta G. And you can substitute the values of F1 and substitute values of sine theta and cosine theta, and you got your answer. Everyone understood this? Now, next problem. Now, this problem is slightly interesting. Now, what you have is in this problem, you have this particular force which is at some angle. Now, if you remember, I gave you this important relationship, and I want to repeat it once again. So what you have is, if you have a force And I'm gonna call this angle theta. I'm gonna call this angle theta x, because this is the angle made with respect to theta x. And I'm gonna call this angle theta y. I'm gonna call this angle theta y. Since I'm looking at a perpendicular coordinate system, x and y, they are perpendicular, I know for the fact that theta x plus theta y is equal to 90 degrees. Theta x plus theta y is equal to 90 degrees. Now what I'm going to do is, I'm going to resolve this component. This is going to be f cosine theta x, and this guy is going to be f cosine theta y. So if I want to represent this f, this can be represented as f cosine theta x I plus f cosine theta y g. These cosine angles, this is called as the direction cosine. This guy is also called as the direction cosine. What is direction cosine? Direction cosine is nothing but the angle made by that vector with respective positive axis. So the direction cosine is about x is the angle made by this vector, cosine of the angle made by this vector with respect to x axis. Direction cosine in y is cosine of the angle made by the vector with respect to y. So these are the direction cosines. Now remember a very important relationship between the direction cosines. You can see from here, since theta x is equal to 90 minus theta y. You agree with me? So if I were to say cosine theta x square plus cosine theta y square, what should be my answer? We know the cosine theta x square. I can say theta x. So I say cosine of theta x is equal to cosine of 90 minus theta y. You agree with me? What is cosine of 90 minus theta y? Sine theta y. You agree with me? So which means cosine theta x is nothing but sine theta y square plus cosine theta square theta y, and the answer is equal to 1. So which means, please remember, cosine square theta x plus cosine square theta y is equal to 1. This is a very important relationship. This is the fundamental relationship that defines direction cosines. Now, resolving a force in 3 dimensions is extremely simple as long as you know the angle that is made by that vector with respect to positive x-axis, positive y-axis, and positive z-axis. Now, I want you to look at the figure that is shown over there. I want you to look at that figure that is shown over there. Is that a 2-dimensional figure or is that a 3-dimensional figure? It's a 3-dimensional figure. You agree with me? That figure There are three events over here. Now, this problem is extremely important. So, do you agree with me that when I look at that figure, very closely, what do you see? You see this force. You see this force. You see the angle made by this force with respect to positive x-axis. You agree with me? Everyone? With me? You see the angle made by this force with the positive y-axis. But have they given us the angle made by this force with respect to positive z-axis? No. However, since this is a triad, I know for the fact, if I say theta z, I'm going to say theta z is the angle with respect to z. So if I say theta z is equal to angle with respect to z, I can use this relationship cosine square theta x plus cosine square theta y plus cosine square theta z is equal to 1. Do you agree with me? Are you with me so far? And why is it? Because direction cosine relationship will always be valid. In a triad, the cosine square of angle made by the vector with respect to the coordinate frame, once we square and sum it, it has to be always 1. Now please note, theta x is given to me. So I can say cosine square theta x is 50. Cosine y is given to me. Cosine square 60 plus cosine square theta z is equal to 1. Can you find out the value of theta z? Are you with me? 50 degrees is given to you. 50 degrees is given to you. You can find out the cosine of 50, cosine of 60 square, and then subtract the sum from 1, take the square root, and find the inverse cosine that should be able to give you theta z. Everyone understood this? Any answers? Now, I have already solved this problem, so I get answer from you. Once I know theta x, once I know theta y, once I know theta z, if I want to express this force as a Cartesian vector, how can I express it? Correct. So to represent force as the Cartesian vector, I would just say F, which is the magnitude of force, which is 450 cosine theta x I plus cosine theta y j plus cosine theta z k. Are you with me? And that is the Cartesian vector. So I would write 450. Theta x is 50. Cosine 50i plus cosine 60j. Does anyone know what is theta z? Huh? 125. So cosine 125. Yeah, so the answers are given to you. So actually, as a matter of fact, solutions are also given to you. So please verify that this is a very important problem. I want you to remember, or I want you to look at this problem one more time and make sure you understand the concept. In this problem, it's a three-dimensional force system. The force is not aligned with x, aligned with y, aligned with z. It is at some angles, theta x, theta y, theta z. In this particular problem, theta z is not given to us. Another important thing, if you look at theta x and theta y, those are the projections of the angle. It means to find theta x and theta y, we are looking from top. Everyone understood this? You find theta x and theta y, you are looking from top. To find out theta z, if you want to find out theta z, you need to look from the side, either this side or that side. So you will have to look from side. You won't be able to find theta z looking from top. You need to see theta z from the side. However, since it's a triad system, cosine direction cosine theta x square plus cosine theta y square plus cosine theta z square has to be equal to 1. With that relationship, we found out the theta z, and then we express this as a Cartesian or a Cartesian coordinate system. Everyone understood this? Okay, next problem. This problem is little challenging, and can I give this problem to you as homework? The issue here is you want to be super duper careful when you identify the angles. I'll walk you through this problem. So please look at this. You have two forces. You have force F1 and you have force F2. And I want you for a minute to focus on force F2. I want you for a minute to focus on force F2 for F2. And tell me what is theta x for F2, what is theta y for F2, and what is theta z for F2. So theta x for F2 is 60 degrees. Theta y for F2 is 45 degrees. And theta z for F2 is 120 degrees. So F2 can be written as magnitude of F2 500 in the parentheses cosine 60 I plus cosine 45 J plus cosine 120 J. Are you with me? Now same jugglery you have to do with F1. The only problem here is the angles that they are written is not very clear. So you want to be super duper careful when you find out those angles. You want to be super duper careful when you find out those angles. So you can also find for F1, please find theta x, please find theta y, and please find theta z. This part I'm going to give you as homework. And if you have any questions, please look at the solution manual. Now here, same logic. Now you have to find out the magnitude and the direction of these forces. So what's happening here? You have how many forces we have? We have two forces. We have F1 and F2. Same thing. What you need to do is you have to look at force F2. F2 is 525. You have to find out theta x, which is 45. Theta y is 120. Now, a word of caution. Whenever you are measuring the angles should be with respect to positive x, positive y, and positive z. You should not go the other way. So can you see that theta x, theta y, and theta z, all these angles are with respect to positive coordinate systems. So x, y, z, the right hand coordinate system, and these angles are theta x equal to 45, theta y is equal to 120, and theta z is 60. And then you can find out F2 is equal to 525 cosine 45i plus cosine 120j plus cosine 60. Are you with me so far? Now the problem happens. Now let's try to solve this problem. Now what is happening with F1? F1 is 450 newtons. So you have F1 is equal to 480 newtons, 450 newtons. Can you see that this force F1 is in YZ plane? Can you see force F1 is in YZ plane? So if I were to show you the YZ plane, this is your Y, this is your Z. So you have five, 3, 4. This angle theta is same as this angle. So cosine theta is 4 by 5. Sine theta is 3 by 5. So F1 is going to be, F1 is going to be 450 cosine theta minus cosine theta k plus sine theta g. Are you with me? So when I take the cosine component of this 450 multiplied by 4 by 5, I get k. So I'll just write it in meter form. Is going to be 450 0i, because there is no component, plus 3 by 5 j minus 4 by 5 k. Now let me ask you this. The next question that may be asked to you is, what is the resultant? You have force F1, you have force F2, and if you have to find out the resultant, what will you do? You will add all the I components, all the j components, and all the k components. So if I were to ask you what is the resultant of this guy, you would say F1 plus F2 is equal to 525 cosine 45 I plus 525 cosine 120 plus 450 times 3 by 5 j plus 525 cosine 60 minus 450 times 455. Do you agree with me? And that is going to be the resultant. If I were to ask you what is the magnitude, so this whole thing can be written as, I'm gonna just write this, f of x I plus f of y j plus f of z k, and the resultant is going to be f of x square plus f of y square plus f of z square square root. Are you with me? You guys are getting hang of the problems? Okay. Please note, this is not a spectator sport. Even though I may solve 100 problems, unless you work out the problems, you are not gonna master the content. So you can't learn how to swim by watching YouTube videos. That's true. Okay. So what I'm gonna do is, in this problem, can someone tell me, you have to express, you have three vectors. This problem can go something like this. First, express these vectors into Cartesian form. Express these vectors into Cartesian form. What do you have to do? You have to find out the angle made by each vector with respect to positive x-axis, positive y-axis, positive z-axis, and then write the expression force is equal to the magnitude of the force in the parentheses cosine theta xi plus cosine theta yj plus cosine theta z. Everyone understood this? Here you have three vectors. No, yeah, you have three vectors. The good news is f3 is in the direction of z, so we don't have to resolve it. So, but you have f1 and f2. Find those angles, find the resolution, and at the end, dollars to dollars, pesos to pesos. Add all the I components, add all the j components, add all the k components. That is going to be the resultant of this. Everyone understood this? Do you want me to solve this, or you guys good? Okay. No, I want you to solve some problems. I can't just go and solve all the problems, because I won't solve problems for you in your quiz. But work out this problem. This is the same extension of the same problem. The only issue here is, after finding out the component of each and individual force, you have to collect i's, collect j's, and collect k's. And then you'll get the resultant. To find resultant, you have to find out fx square plus fy square plus fz square square root. Everyone understood this? Now this is an interesting problem which I want to actually work out. I will give you a minute to read this problem and kind of tell me how should I solve this problem. So what you have is you have a crane. Okay, that crane has this boom, and then there is a rope or a cable from point A to point B. Do you agree with me that point A to point B has some three-dimensional relationship? Point A to point B has some three-dimensional relationship. Now the coordinates that are x is equal to 80, y is equal to 40, and z is equal to 40. Now, first part is very simple. They are asking you to find out the length of the cable. Second part is they are asking you to find out the angle of the cable. I'm gonna add a bit twist to it. If I say the tension in the cable is 100 newtons, what are the components in x direction, y direction, and z direction? Tell me, how would you solve this problem? Correct? Correct? Now, what I want to do is, just for this problem, let me try to draw a three-dimensional picture. What you have is so what you have. So bear with me. This is your A. This is your B. And essentially what you have is you have a vector. You have a vector from A to B. You have a vector from A to B. Do you agree with me? Now what I want to do is, stretch your imagination, and I want you to look from side view and top view. And we realize it is nothing but a right angle triangle. Do you agree with me? So if I want to find out, the diagonal of a rectangular solid or a diagonal of the brick, you can use your Pythagorean theorem and tell me in a heartbeat, it's going to be 80 square plus 40 square plus 40 square square root. You agree with me? That gives me the length of that rope. Now, if I want to find out the angle, what I need to do is, I need to find out its corresponding. So let me give you x, y, and z. So say this, I'm gonna call y. This is gonna call x. And say you are gonna have Z over here. Let me add the distances. Y is 40. X is 40. And no, X is 80. X is 80. And Z is 40. And what I need to do is, I need to find out the unit vector in that direction. So how would I find out the unit vector? Please try to understand. I have specified my coordinate system something like X, Y, and Z. So I'm gonna say this is my initial point 0, 0, 0. So my A coordinate is 0, 0, 0. My B coordinate is plus no, wait a second. I can't assume. Let me make sure. Yeah, this is right hand coordinate system. So this should work. So this is 80. Then I have 40. And I have minus 40. Now I want to construct the vector AB. I want to construct the vector AB. If I want to construct the vector AB, it's extremely, I want you to understand this. It's extremely important. First and foremost, why did I move the coordinate system from point B to point A? The reason I moved the coordinate system from point B to point A is because I want to find out the coordinate of B with respect to A. And in other words, my force, I'm going to assume in this direction. So always the coordinate system should be where the vector starts. It should not be at the arrow. It should be at where the vector starts. Everyone understood this? That's why I assume coordinate system over there. Once again, is it a right hand coordinate system? It is a right hand coordinate system. Now, if I want to find out this vector AB, the way I would write this vector AB is 80 minus 0 I plus 40 minus 0 J plus minus 40 minus 0 K. Are you with me? It's simple coordinate geometry problem. You have AB is equal to 80I plus 40J minus 40K. Do you agree with me? What this is telling me is you are at point A. You want to go to point B. You need to travel 80 units in I direction. Do you agree with me? You need to travel 40 units in J direction, and you need to go down 40 units in K direction. Everyone understood this? I want to find out the angles. I'll give you a minute. I found out this vector. How do I find out the angles made by this vector in positive x-axis, positive y-axis, and positive z-axis? Smarter way. No. I want one simpler technique. No. Is this a unit vector? No. So first, I would convert this into unit vector. As soon as I convert it to unit vector should tell me the direction, right? So I need to find out what the n hat is. So n hat is AB divided by magnitude of AB. Do you agree with me? So this is gonna be 80. So I will write down the magnitude of AB, 80I plus 40J minus 40K. And can someone quickly tell me what is 80 square plus 40 square plus 40 square? So can I say this is 80 by 98I plus 40 by 98J and minus minus 40 by 98. Okay. You agree with me? Yeah. Yeah. This is the square root. So that's, yeah. So 98 is basically the square root of that. Yeah. For some reason, my pencil didn't work. And it's not. Okay. What is this? Cosine theta x. What is this? Cosine theta y. What is this? Cosine theta z. It means if I take the inverse of cosine, I got the angle of that vector with respect to positive x-axis. If I take inverse of cosine, I get the angle with respect to positive y-axis. If I take inverse of cosine minus cosine, it's same as cosine, I would get angle with respect to positive z-axis. Everyone understood this? That's what we have asked. So if you want to find out cosine theta x is going to be cosine inverse of 80 by 98. Theta y, cosine inverse of 40 by 98. And theta z is cosine inverse of 40 by 98. And with that, I'm going to stop here. And